Welcome to our YouTube class. I'm Mr. Scovian Odera, chemistry teacher at the Canal School. I want to take you through properties of nitric 5 acid. In our last lesson, we saw how to get nitric 5 acid in the scale known as this acid, we realized that it is a more volatile acid. That means it readily evaporates and it has a lower boiling point. So this acid has got very many properties. One of the properties that I want to mention is that it has a boiling point of about 83.0 degrees Celsius. It has a density of 1.42. There is also colorless liquid. I want us now to look at the chemical properties of this acid. We realize that this acid is 68% pure, and then it means that in its industrial process, we can dilute it to lower the concentration of the acid and use it for other industrial processes. When we lower the concentration of the acid, we will react it with metals. We can react it with metal oxides, and we are going to produce other substances as we're going to see. Now, I want to say that dilute nitric 5 acid reacts with very many substances. It reacts with both metal and metal oxides. But if you look at its reactions with metals, you'll realize that it reacts with metal, produce salt and hydrogen gas for metals which are most reactive. But for the least reactive metals, it also reacts to form salt, but the hydrogen gas is oxidized further to water because this nitric 5 acid is a stronger oxidizing agent. So for the less reactive metals, such as zinc, copper, they will react with the nitric 5 acid to form salt and water. Why water? Is because the hydrogen gas produced is readily oxidized to water, leading to the formation of salt, water, with a colorless gas known as nitrogen 2 oxide. So, for example, when we have magnesium as a metal, then we react it with nitric 5 acid. Then we react it with nitric 5 acid, will form magnesium nitrate. Magnesium nitrate plus hydrogen gas will form magnesium nitrate plus hydrogen gas. The equation is simply balanced. It's just balanced when you put 2 here. So these are solid, this is an aqueous, these are solid, and this is a gas. But when we use a less reactive metal, for example, when we use zinc, then we react it with nitric 5 acid. In this case, we are going to form zinc nitrate. plus nitrogen 2 oxide plus water plus water plus water. And in that reaction now lead to formation of water but not hydrogen gas, because nitric 5 acid is a strong oxidizing agent. So the hydrogen gas produced with the less reactive metal will be readily oxidized to water, leading to the formation of the equation as stated like that. That is 8. You can balance the equation by putting 3 here, 8 here, then putting 3, 42 here, 342. 38, 342, the equation is balanced. So this is a solid, an aqueous, a gas, and this is a liquid. That one is a liquid, and that one is a liquid. That one is a liquid. So we will put, let's confirm if the equation is well balanced before we put here 2, here 4. That is when it is balanced. Now the equation is balanced. So I wanted us to agree that it's a colorless gas. Wherever it is formed, remember it is a colorless gas, but it is readily oxidized in air to form brown fumes of nitrogen 4 oxide. So it is readily oxidized in air to form a red-brown fume of nitrogen 4 oxide. So that acid, this is nitric 5 acid here. We have mentioned that it reacts with the less reactive metals to form metal nitrate, nitrogen 2 oxide, and water. That is because the hydrogen formed is readily oxidized to water. The hydrogen formed is readily oxidized to water. It's readily oxidized to water. It's readily oxidized to water. So it means that let us again look at how does it react with metal carbonates. These dilute acids, that is dilute nitric 5 acid. This dilute nitric 5 acid also reacts with metal carbonates. It also reacts with metal carbonates. Reaction of dilute nitric 5 acid with metal carbonate. I want us to know that this acid also reacts with metal carbonates. Nitric 5 acid also reacts with metal carbonates to form salt, water, and carbon 4 oxide. So salt, water, and carbon 4 oxide. For example, when dilute nitric 5 acid is reacted with sodium carbonate, will form sodium nitrate as water plus carbon 4 oxide. Form sodium carbonate plus water plus carbon 4 oxide. So the reaction leads just to formation of salt, water, and carbon 4 oxide. But the salt is for the metal nitrate. The salt is for the metal nitrate. So when we put 2 here and 2 here, the equation is just balanced. When we try also with copper, when you tie also with copper 2 carbonate, this nitric 5 acid, this nitric 5 acid can react with metal carbonate. That is copper 2 carbonate to form copper 2 oxide. Copper 2 oxide copper 2 nitrate plus water plus nitrogen 4 plus carbon 4 oxide plus water plus carbon 4 oxide. So that one is very possible, and the equation just needs to be balanced. If you put 2 here, the equation is balanced. If you put 2 there, the equation is balanced. 2 in nitric 5 acid, not 2 in copper, but 2 in nitric 5 acid. The equation is just balanced. The equation is just balanced. So it is important to know that acid can also react with metal carbonate to form salt water and carbon 4 oxide. Finally, dilute nitric 5 acid also reacts with metal oxides and hydroxides. Metal oxides and hydroxides. That is a reaction known as neutralization reaction. A reaction known as neutralization reaction. A reaction between acid and a base, which leads to formation of salt and water. For example, when you have nitric 5 acid, then we react with sodium hydroxide. You will form sodium nitrate plus water. We form sodium nitrate plus water. But for the oxides, when you have something like copper 2 oxide, then I react with nitric 5 acid. We'll form copper 2 nitrate. Plus water. We form copper 2 nitrate plus water. So the reaction will lead to the formation of salt and water when both metal hydroxide and metal oxides are reacted with the acid. Very, very much important. When we put 2 here, the equation is balanced. So what is important is that in most of the reactions, for example, the color of copper 2 oxide is black. The resultant solution when you react it with a nitric 5 acid, the copper 2 oxide changes to a blue solution. It's a blue solution which is going to be formed in getting the presence of copper 2 ions. Otherwise, when you have lead 2 oxide, it's also reacting with nitric 5 acid. Remember, lead 2 oxide is a yellow solid. So it will lead to the formation of lead 2 nitrate. Lead to formation of lead 2 nitrate plus water. We lead to formation of lead 2 nitrate plus water. So in that reaction, lead 2 nitrate is always a colored solution, and water is lead 2 oxide is a yellow solid. So there's also some change in the color of the solutions stated. So we have seen that dilute nitric acid can react widely with both metal oxides. They can also react with metal hydroxides. They can also react with metal hydroxides. So let us also look at the concentrated nitric acid. Concentrated nitric acid. Let's just look at concentrated nitric acid. So when you look at concentrated nitric acid, concentrated nitric acid. So let us also look at reaction of concentrated nitric acid. The one which has got high number of hydrogen atoms per unit volume. So concentrated nitric acid, concrete nitric acid, is always a very powerful oxidizing agent. Very powerful oxidizing agent. It's a very powerful oxidizing agent. For example, you realize that it will readily oxidize other substances. For example, we have very many reactions like when you have, for example, this nitric acid. It can oxidize sulfur 4 oxide to sulfuric 6 acid. Well, with it is being reduced to nitrogen 2 oxide and water is going to be formed there. An observation here, the color of, in this experiment, sulfur is always a yellow solid, while sulfuric 6 acid is colorless solution. So there is an oxidation which has taken place here in reduction, where nitric acid has oxidized solid sulfur, yellow solid sulfur, to sulfuric 6 acid. While with it is being reduced to brown fumes of nitrogen 4 oxide. It is being reduced to brown fumes of nitrogen 4 oxide. So it is reacting with other substance just to oxidize given substance during the reaction process when it is concentrated. And by doing that, we shall have seen the oxidizing property of this nitric acid in that experiment. So in exams you can be asked to identify the oxidizing agent. You will say that it is nitric acid. Reason is because it oxidizes yellow solid sulfur to sulfuric 6 acid, while with it is being reduced to brown fumes of nitrogen 4 oxide. Well, the reducing agent in the experiment here is sulfur, because it reduces nitric acid to brown fumes of nitrogen 4 oxide. That is very, very much important. Finally, just to end up, I want to say that this nitric acid, it can also reduce ferrous, it can also reduce iron 2 sulfate to iron 3 sulfate when it is being used in the reactor. It can also reduce iron 2 sulfate to iron 3 sulfate. When with it is being it can oxidize. So it can oxidize iron 2 sulfate to iron 3 sulfate. While with it is being reduced to a brown fumes of what? Nitrogen 4 oxide. So the most important experiment, look at what has been oxidized and what has been reduced, and then what has been oxidized. It's very much important that it has been oxidized because there is a stronger oxidizing agent in that reaction. There is a stronger oxidizing agent in that reaction. So that one is very, very much important for us for your life. Then you need to know at least 1 or 2 uses of nitric acid. One, it is used in the manufacture of fertilizer. Number 2, it is being used in the manufacture of plastics. Number 3, it is used in the manufacture of dyes and drugs. Then it can also be used in manufacture of maybe in purification of some metals, such as gold and what? Silver, such as gold and silver. So that's as far as the nitric chemical and the physical properties of nitric acid is concerned. Thank you.